Students, in this video, we are going to learn testing the significance of the difference between two means with equal and unequal population variances. Difference between the two means. There are two types of t-test cases when the population variance of two normally distributed populations, that is, variance are equal, that is sigma 1 square is equal to sigma 2 square. Variance are unequal, that is sigma 1 square is not equal to sigma 2 square. Equal and unequal variance. Let us assume that the population variance are equal. This is called the equivalent change supposition or pooled fluctuation suspicion. Then the degrees of freedom is given by n1 plus n2 minus 2 degrees of freedom. When the assumption of equal variance are not met for the two sample t-test, then the modified version of t-test is called unequal variance, that is sigma 1 square is not equal to sigma 2 square. In the case of equal variances, standard deviation is given by two formula, that is sample 1 and sample 2. S1 square is sample 1, that is equal to summation over x1 minus x1 bar the whole square divided by n1 minus 1, and sample 2 S2 square is given by summation over x2 minus x bar 2 the whole square divided by n2 minus 1. Now we are going to see an example. Here there are two different types of drugs. Drug A and drug B were tested on some patients for increasing their weight. 5 patients were given drug A and 7 patients were given drug B. The increase in weight in pounds is given below. That is, drug A given by 5 patients and drug B is given for 7 patients. The respective numbers are given by 8, 12, 13, 9 and 3 for drug A, and 10, 8, 12, 15, 6, 8, 11 for drug B are given in the data. So now we are going to test, do the drugs differ significantly with regard to their effect of increasing weight. Here we are going to see an example. The solution given by 5 principal steps, that is started with null hypothesis. The null hypothesis framed like this: there is no significant difference in the efficacy of the two drugs, that is H0 equal to mu1 equal to mu2. Alternative hypothesis is given by there is a significant difference in the efficacy of the two drugs. H1 mu1 is not equal to mu2. The problem was explained in the following table. In this table you can see x1, x2 and x1 minus x1 bar the corresponding values and x1 minus x1 bar the whole square values. Similarly, we are given for x2, x2 minus x bar 2 and x2 minus x bar 2 the whole square. The values are given and the summing value is given by x1 is 45 and x1 minus x1 bar is given 0, x1 minus x1 bar the whole square is given as 62. Similarly, we explained for x2 and the second terms are given by 70, 0 and 54. The t statistics is explained in the following formula, where x1 bar equal to summation x1 by n1, that is equal to 40 by 5 equal to 9. Similarly, x bar 2 is equal to summation over x2 by n2, that is equal to 70 by 7, that is equal to 10. Similarly, the standard deviation is given by s equal to square root of summation over x1 minus x1 bar the whole square plus summation over x2 minus x bar 2 the whole square divided by n1 plus n2 minus 2. So the value obtained is square root of 62 plus 54 divided by 5 plus 7 minus 2, that is equal to 3.406. So the t value is equal to 9 minus 10 divided by 3.406 into square root of 5 into 7 divided by 5 plus 7, that is equal to t equal to minus 0.5. So the t value is a modulus of t, so whatever it may plus or minus we consider as a positive value, that is 0.5. So the degrees of freedom is obtained by nu equal to n1 plus n2 minus 2, that is equal to 5 plus 7 minus 2, that is equal to 10, where nu equal to 10 and the t is calculated at 5% level of significance, so it is given by 0.05, that is equal to 2.23. Here the inference are drawn by like this: the calculated value of t is less than the table value, hence our null hypothesis accepted. Here there is no significant difference in the efficacy of the two drugs regarding increase in weight of the particular study what we consider in our example. Next, in the case of unequal variance, when the population variance are not equal, the sigma 1 square is not equal to sigma 2 square is considered. Here we use the unbiased estimators of S1 square and S2 square to replace sigma 1 square and sigma 2 square. In this case, the difficulty arises because the sampling distribution has large variability than the population variability. Hence, the statistics T is given by x1 bar minus x bar 2 minus mu1 minus mu2 whole divided by square root of S1 square divided by N1 plus S2 square divided by N2. The degrees of freedom for this unequal variance is given by degrees of freedom equal to S1 square by N1 plus S2 square by N2 the whole square whole divided by S1 square by N1 the whole square divided by N1 minus 1 plus S2 square divided by N2 the whole square divided by N2 minus 1. Here we are going to see the other example for unequal variance. So here we consider two salesmen A and B are working in a particular district from a sample survey conducted by the head office. The following results were obtained. State whether there is any significant difference in the average sales made by the two salesmen. Here the number of sales given by salesman A and salesman B are given by 20 and 18, and the average sales are given in the terms of thousands in rupees, that is 170 and 205. Similarly, the standard deviation also given in terms of rupees in thousands, that is 20 and 25. The null hypothesis framed like this: there is no significant difference in the average sales of the two salesmen H0 colon mu1 equal to mu2. Similarly, the alternative hypothesis is given by there is a significant difference in the average sales of the two salesmen mu1 is not equal to mu2. Here the level of significance is fixed at a 5% level, so it is called by 0.05. Similarly, the test statistics is given by T equal to given by the formula x1 bar minus x bar 2 minus mu1 minus mu2 whole divided by S1 square by N1 plus S2 square by N2, and the corresponding degrees of freedom is given as such what we already said in the previous case. So the calculated values are given by S equal to 19 into 20 the whole square plus 17 into 25 the whole square divided by 20 plus 18 minus 2, that is summarized as square root of 18,225 divided by 36, that is nothing but S equal to 22.5. So the T value is obtained by T equal to 170 minus 205 divided by 22.5 into square root of 20 into 18 divided by 20 plus 18. Therefore, we obtain T equal to minus 4.8. Here the calculator of T is modulus minus 4.8, that is 4.8. Here the table value of T is 5% level of significance for 36 degrees of freedom. When degrees of freedom is more than 30, that the T distribution is same as the normal distribution, that is the value is obtained as 1.9. Since the computed value of T is 4.8 is greater than the table value 1.9, so we reject the null hypothesis. Thus we conclude that there is a significant difference in the average sales of the two salesmen. Let us summarize what we have learned so far in this video. In this video, we learned about the assumptions are defined for the independent sample t-test and its homogeneity, properties of sampling distribution and its heterogeneity of two populations are explained, the significance between the equal and unequal population variance is tested. Let us meet in the next video. Thank you.